And so the idea here was that if the phone is that ubiquitous, let's leverage that in unique ways. And what's a very important thing that we need to focus on is healthcare, right? So the intersection of mobile and health.
This is the Discovery Files podcast from the U.S. National Science Foundation. I'm Nate Podker. Computer technology surrounds us and is involved in almost all aspects of our lives. More than half the people on this planet carry a smart device. There's a good chance you're listening or watching this introduction on such a device right now. But what if that device could monitor health functions beyond your heart rate or how many steps you took today? What if it could even take the place of your annual physical? Our guest today, Professor Shwetak Patel, leads the Ubiquitous Computing Research Lab at the University of Washington, where such questions are being asked and answered. Professor Patel, thank you for joining us today.
Well, thank you for having me.
So I wanted to start with kind of your early interest in computers and technology. Were you one of the kids that took your toys apart to kind of see how things work?
Yeah, very much so. I remember when I was a kid, I think eventually my parents realized that I was very much a tinkerer. So it was whatever toy or gadget or gizmo that I was fortunate enough to have, I would take it apart. At one point, I think my parents realized that maybe let's just embrace this instead of getting angry at the situation. Let's embrace it, embrace the curiosity, which is,
right.
Well, I'm very thankful for my parents for doing that. But I guess one interesting thing about that was that at some point they started to get me two of everything, where I would break one open, and then because I couldn't put it back together, at least I would have the other one intact.
Right.
But yeah, it just shows that they really embraced my curiosity back when I was little.
That's awesome. So getting you lots of tools and did you get to were you looking at manuals and things?
Yeah. My usual reading was manuals and instruction manuals and how-to guides. Because I was very much hands-on, did a lot of mechanical hands-on stuff, got into computing early. So I was, I was very curiosity driven just because these things were just so fun and exciting at the time.
Kind of heading towards your work, can we define for the general audience what ubiquitous computing is?
Yeah, and ubiquitous computing is this field it's a very applied field that looks at how computing will be embedded in our daily lives. And most of that's already a reality. So, when I was an undergrad or a grad student, we were just getting to this world of ubiquitous computing where, things that are computing resources and computing capabilities that are in our pocket, in the home, in the car, that's kind of a reality right now. So it's this notion that computing is kind of seamlessly embedded in the world, and then you have this computational capability that's able to do things on your behalf to make your life easier, better, safer, healthier. And so there's that notion of how do you build that technology? What are the applications on top of it? What are the societal challenges on top of that? What are the user interface questions around that? So that's really kind of that area, is the computing is kind of woven into the fabric of society and in the environment, which is kind of how we've always kind of described it in terms of what computer science and ubiquitous computing is.
Right, and a lot of your projects that we'll get into as this conversation happens have really kind of existed in that space where it's maybe things you're not thinking about as an average person.
Yeah.
Which kind of, I'm just going to lead that straight into your first company there, where can you explain kind of that original idea for the first company that you sold to Belkin? And
and also as a researcher, as a grad student, and even at faculty, I'm a very much an applied researcher. Also very excited and interested in translational research, right? So looking at doing the basic science, but also trying to figure out, what are the set of research questions to actually get the innovation out into the world? What are the questions you need to ask and answer to get it translated into society?
Right.
And so I've always had that balance. And so my first company was around looking at how do you leverage simple sensors and machine learning to do energy monitoring and water monitoring in the home. So for sustainability use cases. And so this was looking at, if you can install a single sensor in the home, could you from that one location glean insights about where energy is being used and water is being used? And it was really the combination of a very powerful single sensor and machine learning kind of enabled that use case. So it was more around how can we provide simple retrofits to a home that enables this kind of smart home without having to have sensors everywhere, right? All these batteries and all these kinds of things that are hard to install. But if you had one thing you installed that may not be as accurate, but it's good enough, what could that enable? But then, a
lot less of a challenge getting people to buy in.
Exactly. Yeah. So that was the whole point. Like, easy to deploy was the goal. And but after building that, it's like we realized that, hey, we're also detecting all this other stuff, and so it has applications in not just activity recognition but also sustainability. And so we spun out a company around this called Zensi, and we were fortunate they got acquired by Belkin, and so that led to Belkin's Wemo division. So Wemo was their home automation division that had energy monitoring devices, water monitoring devices, which you can actually buy from them now, which is really cool. Did a lot of work with the federal government on monitoring energy buildings, smart meter technology. Also, the home automation platform that Wemo is, the Wi-Fi based home automation platform came out of that. So it was really cool to be like the forefront of like the whole IoT movement at the time. And this was a while ago. This was more than a decade ago.
Right. But now you can see where it's in a lot of people's houses, a lot of new construction now. That stuff is just there from the get-go.
It's already there. Yeah.
Right.
Yeah. So that's been really cool to see that, come to fruition.
I think that leads well into the second company, which is sort of iterating on that idea a little bit, to my thinking anyway, of getting that more of a low power source
that's right.
kind of situation.
Exactly. Yeah, so the first line of work really was out on single sensors, but single sensor can only go so far, right? We were able to do a lot with a single point sensing solution, but at some point you do need multiple sensors. So you have, how are you going to detect, humidity changes behind a wall, or maybe mold or leaks that might be in a wall, and so you can't get away from a distributed sensor approach. At some point you do need to distribute these sensors, but then the issue is that if you have 100 of these, are you going to change the batteries? People don't change the batteries of their smoke detector, so let alone 20, 30 sensors. So the idea was go super low power, but it still leverages this idea of using the infrastructure that's already around you. So in this case, this was a little device that talked to the wiring in your house, and the wiring in your house is your antenna. So you don't have to speak as loudly, right? You don't have to send the signal as strongly because the wiring is all around you, that allowed you to turn the power down on the sensor. So this little sensor could last like 25 years on a little coin cell battery. So
that's crazy.
Yeah.
Where was there any specific place where that was installed in the house? Was like, I think that's the part I missed. Where is it at the power box? Is it just in any electrical doors?
Yeah, and this is a project that was a while ago, and I happen to have it on my desk. So this was the original prototype, actually.
Oh, nice.
So this is one of my students. The thesis project for my student was this, and I think it's still running. So I check it every now and then. And so I told them, it's like, hey, when you do your thesis, I'm going to check the battery. If the battery's dead, then I don't know. It's a questionable thesis, right?
Right.
But yeah, it's still running to this day. And again, this has been about a decade.
That's amazing.
But the idea is it's general purpose. So you could literally put it behind the wall. If it lasts 25 years, put it behind the wall. If people are doing remodeling every 25 years anyway. So, but yeah, the attics, crawl spaces, put them under fridges. But so it's fairly universal in where you can put them.
I want to kind of talk about some of the awards and grants and funding you've had.
Okay.
Can you kind of talk us through what you were able to do with the Career Award and with, say, the MacArthur Fellowship, the Genius Grant? How did these kind of things impact your career?
Yeah, I mean, it's a great question. I mean, I'm very fortunate to have had awesome undergrad, graduate school experience, great mentors throughout my career, and I think the thing that's really been great about the Career Award, the PCASE, the MacArthur, is that it validates the work more than anything. Because my style of research when I graduated was a little different. Because one of the things that people often said is like, are you a systems researcher, or are you a HCI researcher, or are you networking? And the fact that people couldn't really figure out exactly what kind of researcher I was, or at least what field, was, I think, in my mind, a good thing. Because that's where obviously the interesting things happen, is at the intersection. So I never wanted to be pigeonholed in a particular area. I do have a community or set of communities. Now I do a lot of health research, so my community is even broader. But I think what those awards recognize is that style of work can have impact, but it's a different type of impact, right? And so because I'm so applied, there's always this thing is like, well, how do you gauge an applied researcher, and what are some of the metrics you might want to apply? And so I think that was one big thing, was validating that like this style of research is okay. And I think my students have benefited, my colleagues have benefited, my junior faculty that we mentor have benefited. So I think that's one big thing that I think what was huge is it validates the style of research.
Right, and just underlines that you're going in the right direction.
A different direction.
But I mean, what your instinct was is for you working out in a way that other people can be like, yes.
That's correct. That's right. Yeah, and being able to balance, academic research with the scientific knowledge you're building on top of everything already out there, in addition to also having this industry and also societal impact in a different way. Right. It also is you can define impact very broadly. It's not only writing papers. It's also other ways of getting that work disseminated.
Right. So I want to leap off of that idea of disseminating your work, and you mentioned working with more health topics lately. One of the things that's interesting is you're taking, say, smartphones and finding whole new ways to engage with things that we can do with them. Yeah. So can you talk a little bit about those advances?
Yeah. So and again, there's like a theme, right? So if you look at the work from the first project and the second project, leveraging existing infrastructure, it's kind of the through line for all the work I've done. But another ubiquitous infrastructure is the phone, right? You've got so many phones in the world, and you've got almost the same number of phones as people in the world, right? So that's a pretty powerful platform. And so the idea here was that if the phone is that ubiquitous, let's leverage that in unique ways. And what's a very important thing that we need to focus on is healthcare, right? So the intersection of mobile and health is an interesting one, right? And people are already doing research and looking at how to use the phone for like data collection, for surveys and those kinds of things. But why not leverage the sensors on the phone, which are getting better and better for health monitoring and so health screening. So the camera can be utilized. You've got like accelerometer, gyro, the touch screen. We recently showed that you can do glucose monitoring with a very simple low-cost strip that's just laid on the touch screen of a phone, and you don't need any other extra electronics. I mean, that's just amazing capability that you can democratize kind of healthcare in that way, right? And so, this was work that we started also a decade ago too. But health innovation also takes time, right? Because you've got to get the data collection, the studies, clinical buy-in. And it was really fascinating. Like one of our first projects was using the microphone for pulmonary assessment, like for people with asthma, COPD, without any attachment. It was called SpiroSmart. And we had some clinical collaborators that were amazing, and they were really bullish on this, and we worked closely with each other. But at the time, the buy-in from the clinical community was they just didn't know how to think about this. Like a phone can never do that. What is that, right? Phone apps are cheap, right? So there's this gut reaction that phone apps are not high quality. So I think breaking through that was really tricky until we were able to show the clinical viability. But now, I mean, mobile health sensing on a phone, it's a whole field now. So it's cool to see all this stuff kind of build off some of our original work. It's like all around us now in terms of that type of research. So that's been really exciting to kind of trailblaze that area.
Absolutely. And I think segueing from there, one of the other things you're working on is wearable technology. I kind of wanted to hear what your thoughts are on integrating different things into the bits of clothing we wear.
Yeah, that's a great question. I mean, the phone is a really good one because it's already ubiquitous. People have it with them. Right. But again, it's limited, right? There's only so many things you can do. A lot of those things might be more spot check type things where I'll do a maneuver or diagnostic. But wearables enable, wearable is more continuous, right? So the whole point of the mobile solution is that people may. There are a lot of things that happen between clinical visits, right? And so that's an opportunity for us to get ahead of any issues that might be arising. But wearables take it one notch further, where it's like the best signal you can get is a continuous signal of your physiology. So wrist-worn devices, so smartwatches are starting to get more popular. So that's a location that's interesting. But now the ability to fabricate and prototype sensors inside of clothing and fabric is another one. So we're investigating all those things, even starting to do some things around jewelry. So looking at how jewelry could actually be part of that equation as well. So I think those are, and those things are worn in different parts of the body so that they're better at doing certain types of physiological sensing than other parts of the body. So, but so that's an area that we're looking at for sure.
Like with jewelry, is this like thinking rings or like a necklace or something?
Yeah, thinking like earrings and necklaces and those kinds of things. Primary earrings and necklaces. Yeah.
Rings. Interesting. Yeah. Is there any bit of kind of following that line that's more difficult than others when you're thinking about trying to implement sensors?
Yeah. So I mean, there's a couple of different things. I think one is it's like this because our research is so applied and translational. We're always designing things that have an eye towards, is that going to be practical or not, right? And so we could build the device in a way that can get the data, get the paper published, show the viability, at least show the proof of concept. But because we try to get these things deployed in situ, we always have to kind of look at, okay, we have that constraint, right? And so that makes it really tough. So it requires a ton of engineering that typically, in a basic science lab, you don't necessarily, try to do because you want to show the proof. You want to have the proof of concept. Let's show the viability of something. But we have to kind of do both. And that makes it a little bit onerous where, the type of prototype, the fidelity that we need to build with, the level of robustness is a bit higher than if we didn't have a lot of these large scale studies that we try to enable with our projects. And so I think that's a difficult one. So it makes it, so the engineering and the research have to go hand in hand right now, which I think a lot of academic researchers are starting to do. Like if it is or isn't hardware, even like a lot of the work in AI requires a huge amount of compute. And so to make those things practical, I think a lot more people are having to kind of invest in, like their grad students doing a bit more engineering to get these things deployable.
Right. So having brought a couple of these kind of things to market, can we talk about your experience with that? What part of it was the most difficult for you? Is it more of a matter of fine-tuning the device or getting the buy-in from people?
Oh, that's a great question. It's a little bit of everything. I mean, I think so at the end of the day, being an academic and an entrepreneur, there are a lot of similarities in the sense that you have to be able to succinctly demonstrate and pitch and pitch your ideas, right? It could be to the National Science Foundation, or it could be to a set of venture capitalists or VCs. It's so being able to show that vision is very important. So there's some similarities there. But I think that one of the big challenges has really been around the way you approach both are a little bit different, right? The innovation path might be similar, but they're very complementary. So that's the thing that I found exciting is the complementary part of it, is that when you do a startup or when you're trying to translate these things out there, you actually find new research opportunities that you would never have discovered if you hadn't gone down that path, right? So I think that's the other thing that's really exciting.
Ooh, I feel like I should ask you about that. Can you talk a little bit about learning from failure or having something not be quite as you intended it to be, being an opportunity to go in a different direction? Or
I mean, and that happens quite often. I mean, if I use some of the examples of the energy work, right? So when we started to, as a part of the startup, started to deploy some of these things, we found issues in the real world that we just never even thought of from the lab. And that opened up new research areas that we could have gone down, right? It's like, hey, let's go down this path of technical inquiry, which never would have come up, right? Never would have come up. And that's happened across the board in some of the low power sensing work and even in the health work. In that case, working with clinicians, payers and providers, we found, holes or challenges that in the literature you would never have seen. And so these are problems that are academic research problems that now we can start to tackle that actually could have a direct impact on society, because now we've seen some of those issues. Things like, if you have wearable devices, like wearability, how people wear it, how people don't wear it, what they think about, these devices. Or is it left-handed or right-handed? Like, these are simple things in retrospect, but that's the reality of the situation. If you wear a device very tightly, you're going to get great signal. If you wear it loosely, it's not going to give you a great signal, and that's the reality. And if you make a research problem around how do you do accurate heart rate tracking with a loose worn device, it's an interesting research problem, right? And so that comes back to the academic community where we can solve that problem that has a lot of downstream impact, right? Whereas in the without that context, we may have constrained that problem artificially to make it easier for us, but does that have that same impact or not? So I think that's why I think they're both very complementary.
Thinking about your role as a leadership of a large lab, Can you talk a little bit about how important mentorship is and kind of setting people up for success?
Yeah. I mean, I think that's paramount, and that's why I come in every day, and I'm excited to work with all my great students. Is that enabling their careers is my number one priority, and the thing that excites me the most, and that's what I'm passionate about. So mentorship is very critical. But my style of mentorship is one that is hands off but hands on when needed, because if you're too hands on, then you have then the successes and failures of your students are basically you're kind of prescribing, or you're being a little bit more prescriptive about kind of what they're doing. So you have to be just hands off enough so they can explore and they kind of see, okay, that didn't work, and then I'm going to try this path, but nudge them and create the guardrail so they don't go so far off, right? So it's a tricky balance, but I think that the balance of hands on, hands off, it's more dynamic, right? So I have a more of a dynamic style.
One of the last kind of areas I was interested in asking you about is, can you talk a little bit about your work with Google and what kind of things you've been advising them with or working on?
Yeah, so example, I'll give an example on the phone actually.
Sure.
One example on the phone is that so on the Pixel phone, you can actually do heart rate tracking with the camera and respiratory tracking with the camera. And so this was work that we had done with the camera and the heart rate monitoring, like non-invasively. So similarly, kind of how you do it with the watch, where you have the optical monitor on the wrist. But in this case, if you're holding the phone, you have your finger over the camera, or if the camera's looking at your face, you can get respiratory rate that way, or heart rate with your finger. So this was work that my lab was doing for many years, where we did a lot of validation studies, algorithm development, but the bar to get this into a consumer product is very high. You've got to look at skin tone. You've got to look at diversity of the types of phones. If it's an Android, you have to have all the different types of phones, right? What happens if the camera is smudged with smudged up, right? So there's a lot of things we have to, and so that's really hard to do as an academic lab.
Very, very cool. So as we're wrapping up, I want to talk to you about the future. You were talking about how you're thinking a lot about what's 5 or 10 years ahead. Yeah. And one of the things that I know I saw mentioned was doing biodegradable sensors.
Oh, okay. Yeah.
And things like AI and working in machine learning and all these things into what's ahead. So what are you excited to be working on in the future? What are you imagining that we haven't even thought of yet?
Yeah, and I mean, there's so many things to do. I mean, in the health space alone, there's so many things happening. I mean, there's, obviously with generative AI and advanced AI now, like there's so many new things we can do there. So I think we just scratched the surface with the sensors that we have in the phone and the wearable. I think those are going to get better. Then when you supercharge them with AI, the sky's the limit in that case. And we're already starting to see that, being able to predict and diagnose things early, getting ahead of any challenges that might happen because of these things. So I think that's one area I'm super excited about. So looking at how to automate and a lot of these, the output of the sensors, like automate in terms of what you can do with it. So give you actionable feedback there. The other one on the hardware kind of sensor innovation side, some of my colleagues and I are working with students that are looking at, not only, taking the practicality question forward, right? So we talked about some of the sensors that we built that use the power line as the antenna. That was to reduce the battery, right? Like the need to replace the battery. But you still have a battery. You still have a printed circuit board. So when you have 1,000 sensors, what happens when they stop working, right? So when we think about from a sustainability standpoint, what do we do with these plethora of sensors? So then pushing the envelope of, well, let's go all in on truly biodegradable sensors. It's a very hard problem. So you have to have a set of stepping stones. So one of the first efforts were around, let's focus on PCB boards. Let's make PCB boards that are truly recyclable, right? And so, and then take it to the next step. So we've shown the ability to build Vectromer-based PCB boards that you can actually recycle. You take the components off of it, this thing can be essentially melted down, and you can reuse that. So that's one thing. That's one step. Printed circuit boards are not easy to recycle. Let's make that easy to recycle. The next step that we're focusing on is literally a very simple sensor that is end-to-end biodegradable. Right? It is power harvesting. It has so there's no battery. Obviously the circuit board's biodegradable, but components that we can build there. And then we're going back to, fundamentals now. Like these are very simple. There's no ICs in these things. They're very simple JFETs. But I think you need to have a starting point you have to start somewhere, right? But I think that is going to be really interesting. So I think the need for kind of translational and applied research, I think this is the best time to do that kind of work, because you literally have every tool at your disposal, and bringing them together and being us as mentors, encouraging students to try to tackle these societal problems where computing is the a tool to kind of tackle those. I think we need to do more of that. I think we need to encourage our students to if they want to do that, well, let's encourage them to do more of it, because the tools are available. Because it used to be where you had to become an expert in some of these areas to even be able to innovate in them, right? Now you can innovate broadly, and that breadth of innovation is really, I think, gonna come up. I think will enable our students to come up with some great ideas, and so I think fostering that environment is going to be really important.
Right, really, really fundamentally important to securing a future of anything happening at all.
Yeah, for sure.
Awesome. Well, thank you so much for your time today.
Yeah, thank you. Yeah.
Special thanks to Shwetak Patel. For the Discovery Files, I'm Nate Podker. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.